All right, welcome to the dimensional analysis review. I'm just going to be going through the process of using unit conversion to solve problems with a few more examples and reminding you about the method that you probably learned in Regents Chemistry, which was called the T-chart method. Now, the reason that we call it the T-chart method in Regents Chemistry, but that I'm going to call it dimensional analysis now, is because realistically, dimensional analysis is a polysyllabic term that, quite frankly, probably scares a lot of Regents Chemistry students, so we call it something nice and simple in Regents Chem, T-charts. But we're going to call it by its real name here, which is dimensional analysis, but it is the same exact process. So to remind you of what this process is, the first step that you want to do is draw the T. Then you take the number that the problem gives you, not the conversion factor if a conversion factor is given, and you take that number with its unit and you put it in the top left-hand corner. This is essentially where you're going to start your conversion. You always start your conversion with the value that the problem gives you. You take the units then that are in that top left-hand corner, you drop them down to the bottom right. What you're doing there is canceling units. If the same value is on the bottom and the top of a fraction, it cancels out. And that's what we're doing. So you take that unit, drop it down, you put the other half of the conversion factor unit in the top right hand corner, like say 12 inches might go in the bottom right, and 1 foot might go in the top right. It's a conversion factor, these two equal values but with different units. 12 inches is 1 foot. Then you stick the numbers in front. You always want to let the units be your guide. And you're going to see me filling in units first pretty much all year long. The units are the guide in dimensional analysis. They're showing you what to do next. You're saying, well, if you put this one on the bottom, then you should put this other one on the top. You're filling in units, and then you put numbers. What's the number that goes along with that? So it's not really about numbers, but it's much more about the units. Once you've essentially once you've gotten rid of all the units that you don't want and you have the unit that you do want, then you can grab your calculator and do some math. What you've set up is basically a really big long fraction. You multiply all the numbers on the top together, you divide by all the numbers on the bottom, and that's going to be your answer. The unit that's left is whatever unit you did not cancel. The reason that we do dimensional analysis is because in AP Chemistry, rather than other ways of converting units like proportions, is because, frankly, proportions take a really long time. We are going to be dealing with problems that have multiple steps, multiple conversion factors. A minimum, realistically, is going to have a minimum problem in AP Chemistry is going to have 2. Much more common to have 3 conversion factors in a problem. And if you're sitting there trying to do 3 proportions, frankly, that's eating up valuable time. Whereas if you do it with dimensional analysis, you simply set up all the unit conversions, and then you're going to your calculator once instead of 3 times. And later on in this year, we're going to do some dimensional analysis problems that are going to have 7 or 8 steps. Much easier if you get this concept of canceling units just by setting up a dimensional analysis, a whole bunch of T-charts, going to be much faster for you. So, examples using conversion factors at the back of your textbook. If you don't have your textbook, pause the video, go grab it, open up to the very back, because I'm going to be converting some metric units to English units and vice versa, and you probably don't know these conversions off the top of your head, nor would I expect you to. Okay, so you have your textbook? Good. Sample problem. A standard American football field is 100 yards. How many millimeters is this? So using the stuff in the back of the textbook, we want to go yards to millimeters. Let's kind of sketch this out first and then figure out what factors we're going to use. Well, if you look at the back of the book, there's nothing that's direct for yards to millimeters, but we do have yards to meters. There is a conversion factor there. Okay, so we can do yards to meters, and then we can do meters to millimeters because this is metric. So we've changed the prefix. That's a factor of 10, usually 10 to the third. So we know that. It's not written in the back of your book, but hopefully you're comfortable with that. So this is the step that we're going to do. This is going to be a 2-step conversion. Yards to meters, this is going to be step 1. Meters to millimeters is going to be step 2. So just sort of thinking about how we're going to convert the units first. Now, we're going to go in with our dimensional analysis with our T-chart. So take the number the problem gives you, 100 yards. Put it in the top left corner. We want that unit to cancel, so we're going to put yards on the bottom right, because if it's on the top and it's on the bottom, it goes away. Now, looking back up here, we want to turn yards into meters. So meters is going to go on the top. Now we're going to look at what the numbers say in the back of the book. And it says that this conversion, meters and yards, 1.0936 yards is equivalent to 1 meter. That's taking care of the first step. But we're not done because we want millimeters. No biggie. This now becomes, the 1 meter now becomes essentially the top left-hand corner. So I'm going to take that meter and I'm going to drop it down, and I'm going to put the unit that I do want, which is here, this conversion factor, millimeters on the top. There are two different ways that you could plug this in. The way that I like to, I always tend to think of it, 1 meter. How many millimeters are in a meter? What is that relationship there? You need to know this information. There are 1,000 millimeters in a meter. A milli is 1,000th of a meter. So if I have 1 meter, it's going to be 1,000 millimeters. You could also have put you could have changed these numbers around, because it could have said that 1 millimeter is 1/1000th of a meter. That's acceptable. A couple different ways that you can do it. You're going to get the same answer, though, in the end. Meters have canceled out. So we're going to do 100 times 1,000 on the top, then divide by 1.0936 yards on the bottom. And we should get 9.14 times 10 to the 4th millimeters. That's an easy one. Let's do one that's a little bit more involved. When I back out of my driveway in my car, I cover a distance of 25.0 meters in 15 seconds. What is my speed in miles per hour? Now, I restricted myself to just conversion factors that are listed in the back of your textbook on this one. Now, we want miles per hour. We have meters per second. We have 25 meters in 15 seconds. So start off by drawing the T. It's actually going to be a little bit different. 25 meters is going to go on the top. 15 seconds is going to go on the bottom. And I'm going to say this right here, that before I continue any further with this problem, there are many different ways that you could approach this using dimensional analysis. If you wanted to, you could essentially do two T-charts. One for the 25 meters, where you turn the meters into miles using conversion factors, and the second T-chart for the 15 seconds, where you take the 15 seconds and you turn it into hours. You would then have miles and hours. You divide the two, miles by the hours. That would give you the final speed in miles per hour. That's perfectly acceptable, and I'm not going to tell you that that's wrong, because it isn't wrong. And it is using dimensional analysis, and that's the point. However, I'm going to show you how you don't even need to do two T-charts. You can do this with one really long T-chart. We're starting off with meters per second. The reason I'm putting the meters on the top and seconds on the bottom is because this is a fraction, 25 meters covered in 15 seconds. I want miles per hour, so I want distance on the top and I want time on the bottom. That's what I have here. And then we're just going to do unit cancellation until we get to miles on the top and hours on the bottom. So I'm going to deal with the meters first. Okay, I'm going to deal with the meters first. I'm going to get that meters turned into miles. Using the conversion factors that are at the back of the book, the most logical way that I saw of doing this, there is no direct way for meters into miles. We do not have that conversion, but we do have meters to yards, yards to feet, feet to miles. Now, yards to feet is not written in the back of the book. Hopefully you know that off the top of your head. So, meters on the bottom to yards. We did this one last time. This is 1.0936. Why am I doing that? Because that's what I've got listed in the back of the book. You could approach this, you could say inches and then inches to feet and then feet to miles. That works too. This is the way that I saw. Meters has canceled. Okay, basically now we've got yards per second. We don't want yards per second, we want miles per hour, but we're dealing with turning the meters into miles first. Okay, so that's gotten rid of the meters. Now let's deal with that yards. The reason that we wanted yards is because we could put yards into feet, and we have a conversion factor for feet to miles. So hopefully you know that for every 1 yard, we have 3 feet. That's a very common conversion factor in English. Okay, so we've got feet. Now we can use the 5280 feet per 1 mile. You'll notice that I'm almost always filling out the bottom number first. I'm always going to be doing that throughout the year. It's about unit cancellation. Feet have canceled. Great. If I stopped this right now, I would have miles on the top and seconds on the bottom because these are the units that have not canceled. But I don't want miles per second, I want miles per hour. I have taken care of the meters. That's done. I've gotten the meters turned into the distance unit that I want. Now I'm going to keep on extending my T-chart and deal with the seconds unit. Now things are going to be a little bit opposite here because seconds are starting off on the bottom. So where do I want to put seconds? Over here, I want the unit to cancel. Seconds are already on the bottom, which means that I want to put seconds on the top. And I am going to go through and do this the long way. 60 seconds is equivalent to 1 minute. Seconds have canceled. I now have minutes on the bottom, but I don't want minutes on the bottom, so this is an extension of the T-chart, so this is still going. I've got minutes on the bottom. I don't want minutes on the bottom. I want hours on the bottom, so I have to put minutes on the top so that the minutes cancel and hours on the bottom. There are 60 minutes in 1 hour. The minutes are on the bottom and the top. They go away. Now look at what we've done with our units. The only unit that remains on the top is that mile. The only unit that remains on the bottom is the hour. In one T-chart, I have turned 25 meters per 15 seconds into miles per hour. I only have to go to my calculator realistically once for this problem. And when you go through all this math, multiplying the top together, multiplying the bottom together, and then dividing, you should hopefully get 3.73 miles per hour. And that's using dimensional analysis, and that's what we're going to be using for unit conversion in throughout the year. That's what I'll be requiring you to show me on tests and quizzes when I'm asking for your work.